For the half turn of this problem, let's try to solve the formula or use the formula. You have the half turn of your alpha and your beta for your x is identified as the minus of that x plus twice p. So what we just need here is just the p. P is the intersection of both lines. So we just simply need to use here a certain solution of a process of elimination to identify the point P. But before we go to that, let me allow me to illustrate that in our Cartesian plane. So our point is at 4, 0, somewhere here, assuming that the H grid is 0. That's 4 and 0. Okay? Let's just simply illustrate that and so that we can have a checking, of course, later on. And allow me to graph lines alpha and beta. So by determining the intercepts, if you are sure with the process immediately and you don't want to see the graphing portion, you may skip the video to the point where the graphing is already done. But in this case, again, allow me to graph this using intercepts. Okay, and then you have for your beta, you will have x plus 2y equals 2. So for this one, let y be equals 0 for x-intercept. So 2x minus 0 is equal to 2. 2x is 2. X is equal to 1. So we have here the x-intercept at 1 and 0. For your y-intercept, let x be equal to 0. So this is our equation. So we will have here 0 minus y is equal to 2. Negative y is 2. So y is negative 2. The y-intercept is at 0 and negative 2. How about for our beta? So let y be equal to 0. So x plus 0 is equal to 2. X is at 2. Okay? And then its x-intercept is 2 and 0. For our y-intercept, let x be equal to 0. 0 plus 2y is equal to 2. So you will have here, 2y is equal to 2. Y is 1. So you have here 0 and 1. Okay? So with that, we can actually plot this on our Cartesian plane. Our alpha is at 1, 0. So it's here. And 0, negative 2. It's here. So by connecting them by a line, hopefully I could connect them in just one attempt. Okay, I believe it's okay. So we have here this being our alpha. For our beta, we'll have it at 2, 0. So 1, 2, 2, 0 somewhere here. And then 0 and 1. So 0 and 1 is here. So if I'm going to connect that using a line again, hopefully we could come up, okay, 0, 2, 0, sorry, 2, 0, my bad. So it's 2, 0 by the way. It's 2, again, let me do it again, sorry for that. I was actually incorrectly thinking of one thing. I thought it's 1, 0, so it's actually 2, 0. So allow me to graph it in this manner. Hopefully it's more acceptable right now. So we will have here this being our beta. Okay. So what does this tell us? Our point x is somewhere here. Okay. So its half turn along these two lines will actually be located somewhere here as well. Okay. So it might be on the axis, but depending on the presence of our or existence of our point P. So what we need to do here is to determine our point P as needed. So what we can do is to come up with the process of elimination. So for 2x minus y is equal to 2 and x plus 2y is equal to 2. Let me multiply the first equation by 2. So I have here 2x, sorry, that's now 4x minus 2y is equal to 2. You have your x plus 2y, sorry, my bad again, this should be 4. 4, and then you have 2x, x plus 2y is equal to 2. Combining that, you will have here 5x is equal to 6. So your x is actually at 6/5. That's for the x value. Let me use the second. So you have here x plus 2y equal to 2. So that's 6/5 plus 2y is equal to 2. 2y is 2 minus 6 fifths. That's 10 fifths, right? 2y is equal to 4 fifths. Divide both sides by 2. You will get 2 fifths. So our point P is actually at 6 fifths and 2 fifths. That's 1.2 and 0.4. Let's look at our graph here. So it's actually at 1.2 and 0.4. So basically, it's really correct at that point. Okay. Now, let's go back to the formula since we have our P. And again, the purpose of the graph is actually to verify whether our solutions are graphically correct. So we have here the half turn of our x, negative x plus twice p. So negative, our x is 4 and 0. And then you have here plus twice your p, which is 6 fifths and 2 fifths. 6 fifths and 2 fifths. So this is actually negative 4 and 0 plus you'll have 12 fifths and 4 fifths. Combining them, that's actually, if I'm correct, right, negative 4 is negative 20 plus 12. So you have negative 8 fifths and you have your 4 fifths. So this is actually equal to, that's negative 1.3 and 0.8. So it should be here, negative 1.3 and 0.8. So somewhere here. This is actually the half turn. Take note, it did not reach the, what do you call this one? It did not reach the x-axis of the negative side, because if we're going to think about reaching that there, okay, it may look like 180 degrees, but when you look at the concept of our line here, our 180 degrees is somewhere here. This is the connection, okay? It's right in 180 degrees there, right? Because if you're going to really stick with this form, take note, it did not pass our center. Okay, that would mean it's no longer the possible half turn, because our half turn can be illustrated further as it should pass through our point, our center, which is point P. So that is actually, again, this is the correct form, not on the negative x-axis. So basically, let me arrange that. And again, the result or the final location for the half turn is this portion here with coordinates negative 8 fifths and 4 fifths. Okay. So we will have one more example for the half turn on the next video. Thank you very much for watching.